In this video, we are going to introduce a couple of physics concepts, distance and displacement. Let's begin. Distance is defined as the path traveled, a measure of interval between the locations measured along the actual path connecting them. Displacement is the change in position of an object. After reading these two definitions, it may still sound kind of vague. A couple questions can distinctly separate the two terms. The first question, how far did you travel? This describes the distance. The second question, how far are you from where you started? This describes the displacement. There is a driver in this car, and in the lower right hand corner, you'll see a mini-map and a blue highlighted path leading to a waypoint that is 128 meters away. It should also be noted that we are facing in the east direction, as north is indicated at the left of the mini-map. Let's drive to this waypoint. The car reached the waypoint. How far did the car travel? Well, in this case, it traveled 128 meters, which describes the distance. How far is the car from where it started? The car is 128 meters east from where it started. Based on the answers, you notice that displacement has a direction, whereas distance does not. Let's look at one more scenario. Same car, same waypoint. This time we're going to drive to the waypoint and back. We probably should note what building we're in front of. This building with the water fountain here. Again, to determine the distance and displacement, we answered these two questions. How far did the car travel? And how far is the car from where it started? The distance the car traveled is 256 meters because it drove 128 meters to the waypoint and 128 meters back in front of the building. The displacement is 0 meters because the car is exactly where it started. Let's dive into a small physics example. We have a line here with 4 marked points, A, B, C, D, and how far apart they are, and we're to calculate the distance and displacement for the following. For the first, we start from A, go to B, and then to D. Let's go over this one. To calculate the distance, it's a matter of adding the gap between points A and B and between points B and D. The gap between A and B is 19 meters, and the gap between B and D is 32 meters. Adding those two will give us a distance of 51 meters. The displacement is also going to be 51 meters, except we're going to attach a direction with the answer. We can either express the displacement as positive 51 meters forward, or 51 meters east. It's your preference for this problem. A couple details to go over regarding the variable representing displacement. That triangle notation you see is called delta, which means the change in something. In this case, it's delta x, as it is the change in position along the x direction. There is an arrow notation above which is called a vector. If there's a vector above the variable, that means the quantity described has a direction. Using the same line, take a moment, pause the video, and try solving the distance and displacement for C to D to A. For distance, C to D is 11 meters, D to A is 51 meters, which gives us a distance of 62 meters. For displacement, we started at C and ended at A, which is 40 meters to the left, or negative 40 meters. Here are some last details I want to go over. Displacement involves a sense of direction using positive or negative signs. Positive can imply right, up, forward, and negative can imply left, down, or backward. This concludes this lesson on distance and displacement. Hope you found it helpful.